Good evening. By which I mean good morning. Happy Halloween. How is everybody? This very nice Halloween day. I must say the weather is absolutely perfect for a terrible Halloween, just like we ghosts and ghouls like. In fact, I was checking the weather statement, and there's supposed to be a very nice fog rolling in around 7 o'clock this evening, just in time for the little children to get lost in. All professors should have a good evil laugh, I think. So, only 20 people watching, eh? Yeah. Alright. Go ahead and ask me questions. I know you've got them about the midterm tomorrow. Ask me your questions. I will answer your questions about the midterm tomorrow.
at this point in time. Quite a lot of delay. Well, there's usually about there's usually a 10-second latency. We can do a latency test. So I'm gonna clap my hands, and when you hear the clap, just like type clap or do the clap emoji in the chat, and then I will tell you when I see it, and that'll establish what our latency is, okay? All right, so here we go. 1, 2, 3, clap! Oh, there we go. There's the clap. Yeah, that is actually pretty bad. Yeah, the latency is like, 15, 20 seconds at the moment. I should have been. That's okay. So. Questions. Can you have the projector code? Yes, you can have the projector code if you'd like to put me up on the big screen. I will. The projector code is 69672. You didn't hear it from me, but that's pretty much universally the projector code, no matter where you are on campus, unless you're in like pretty much all campus technology or that. All regular classrooms have the same projector code. So, is the midterm tomorrow or Friday? Where was it published that it was Friday? Because it was in my calendar as being tomorrow. Let me see here. Midterm. Is this the correct announcements feed? Yes, it is. Oh, that must be an old one. Yeah, okay. November 4th at 8. November 4th is Friday. Okay, so it is Friday. All right. Right, I remember. We had conflicts. It was conflicting with something on Tuesday. So it's okay, so it's Friday. All right. No panicking then. I definitely didn't forget that and panicked all weekend to put the midterm together, which I suppose is fine. Because, there we go. All right. So, in order. Is the midterm today or tomorrow or Friday? It is Friday. I was mistaken. I apologize for that. Has the kid arrived? Yes. The baby has been born. She's sleeping in the other room at the moment. Cute as a button. I have a picture. Let me show you the picture. Pictures. My home. Pictures. What is it? Pictures. There we go. There she is. She's just like less than 2 hours old in this photo. You can see the wrinkliness, The hat here is to hide the goo that human beings have as their inheritance from biology. When the Bible says dust to dust, I think it was wrong. It's actually slime to slime. From slime are we born, and to slime do we return. So yeah, the kid has been born, happy, healthy, everything that you would want and expect in a newborn child. No indications of any kind of illness. She is doing quite robustly. Actually, she's pretty strong for a newborn. She's even trying to hold her head up a little bit, which is, quite remarkable, because they usually don't manage that skill until they're at least 3 or 4 months old. Oh, at least be able to hold their head up consistently. But and Mum is doing extremely well as well. In general, it was just about your textbook example of everything you could want in your best case scenario for a birth. So yeah, there we go. Where can we see which room the midterm is in? Did I not post that to the announcement? I didn't. All right, let me just scuttle into my email archive and see what bookings told me. Sorry about that. It's gonna be, I believe it's in PGCL, PGCPPLLL, whatever the acronyms are getting longer. We need simpler acronyms. Campaign for Campus Simpler Acronyms. Bookings. Uh-huh. There it is. PGCLL 127. There we go. I'll just post that to the announcements feed. Just because, you know. It'd be good if people not watching the stream knew that too. Midterm room. There we go. Boom. Published. Good, 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 good. Ah, 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 ah. Nya, ah, nya, ah, nya, ah. All right. Does the midterm require the use of external files? The midterm will require you to program C programs in more or less the same fashion that you have been programming them so far. So you will require your computing device. You will require, you know, whatever your C development strategy is. You will need that installed on your computing device. You will be required to download a zip file containing all of your C code stubs for each of the questions. And furthermore, submission will be made through Git in the regular manner, in the manner that we have agreed so far. And when I say agree, I mean you are compelled to do it because I say so. So, I believe I wrote Friday right after Tuesday. Yes, there were a bunch of conflicts. Like, I had booked it, like, it had been booked over an actual class for, like, a lot, like 20% of the class, so I had to move it to Friday. So, there you go. Yeah. Thank you! Yes. Yeah, she is pretty cute. Newborns aren't usually this cute, but that's pretty cute for a newborn. Newborns are usually much uglier than this. Like, just Google a picture of ugly newborns, and if you don't believe me. That's a sampling bias. Shh. All right. Would dynamic memory allocation be on the test, since I don't think we got to that part yet? Well, because I was panicking over the weekend, thinking the test was on Tuesday when it's actually on Friday. I actually got the test, like, all done up, and it's, like, ready to go. Actually, well, it's not quite ready to go. I still have to do a couple of things. But it's essentially ready to go. And I can confirm that I decided not to put dynamic memory allocation on it. Why am I showing you stuff from the other course? Jeez. I decided not to put memory allocation, dynamic memory allocation on it because we hadn't covered it in class yet. And I don't think it's really that fair to put it on it at this point, even though the thing has been extended, because it's too close to the test. I like there to be, like, some interval of material that's not on the test, you know, before the test. So there we go. So dynamic memory allocation is not on the test. Ta-da! Pointers definitely are, though. So, you know, while basically you can call the test cutoff point the end of this section. Okay? The end of the section that we're currently on. When are we going to get the assignment 2 marks back? As soon as I kick Arian's butt. So I'll just make a note. Let's see here. Notes to self. Kick Arian's butt. There we go. All right. Made a note to myself. Yeah. Assignment 2 marks will be back relatively quickly. Definitely in advance. Definitely in advance of the test. Good. Wonderful. So, any other questions? Normally, this is the point where people try to pump me for information of what's on the test. Okay, you want a hint? I'll give you a hint. Knowing how to work with 2-dimensional arrays will be helpful. So practice. Okay, so might as well... Oh, what's on the test? C programming. So, in general, the test material is a... could I accidentally screen share the test? Why would I do that? I'm not like... I don't have your best interests at heart. I'm a cruel force of nature that has to be contended with. I'm not, like, on your side. Why would I help you? Jeez. The whole purpose of me in this position is to weed out the people who don't deserve to be here, you know? That's the whole point. Yeah. At any rate. That's one of the things I like about, like, the character of the vampire is, like, just utter contempt for humanity. Just contemptuous of humanity. I love it so much. Oh, shoot, I studied for Python and Haskell somehow. Ah! Don't study Python. Come on. Jeez. You can do better than Python. What are 2D arrays? How are we going to use 2D arrays on the midterm? Well, you'll just have to use them. I'm not going to... If I tell you how you're going to use them, then that would be giving the question away, and I'm not giving the question away. However, there is a slide on 2-dimensional arrays. Oh, slides. Ah, gotcha. There we go. Check this out. Read that slide. Boom. Yep. Basically, you have multiple indices, right? But it would be useful to know how that actually works in terms of memory. So there you go. The answer is it's just a collection of arrays that are stored in continuous memory as, like, it's just an array of arrays. But you're not guaranteed to pass the test even if you see the questions today. That's probably true, actually. I think it's in the exams folder. Actually, the exams... Wow, you're being generous if you think I've started working on the exam. Woo! Yeah, no. Talk to me in November. It's not even November yet. Jeez. All right. Oh, no. I closed my... Oh, jeez. All right. Enough fun and games. We have to talk about serious business. Because, like, we have... Like, I think we're a little behind. So... So, we're talking about pointer arithmetic, right? So, congruent to previous lectures given on this subject. Oh, by the way, lectures are going to be online this week and next week, possibly another week. We'll see how things go. I'm keeping the option open for the third week because, you know, you never know how things develop. Can 2D arrays be thought of pointers to pointers? Not especially. Okay. Okay. Brief note on 2D arrays. All right. Then we'll get into it. You can actually still use single pointers for them. So, what a 2D array does and is, it takes, you know, a certain let's just imagine this page is memory, right? It takes a certain segment of memory and it puts a bunch of arrays adjacently in memory, right? These arrays are all of the same size. I know they're not, but imagine they are, okay? Right? So it just fills memory up with a bunch of different arrays, right? The first index is which of these you're accessing, right? So you've got array 0, array 1, array 2, etc., right? Within, like, the secondary index gives you which cell in the array you're working with, right? But it's very important to note all of these are still just integers, right? So a pointer to an element in a two-dimensional array is still just a single pointer, right? It would be something like shoop. Shoop-a-whoop. Right? It would still just point to a single element. Like, because all you're trying to get at is a single cell of memory. Now, like, if you want, you can do it with a double pointer, because the first sort of, well, nah, single pointers are better. Single pointers are better in this case. Like, a double pointer, right, is a reference to a reference. So, what arithmetic operation do you perform on this to get, you know, to move through the different arrays? None. What you actually want to do is you want to jump by the array size, right? That's how you would move down using pointers. You would jump n. Where n is the size of the array, to get into the next array. Does that make sense? You guys cool with that? Yeah. Yeah. I believe there are a couple of, like, questions. If you're looking for some practice material, Let me take a look in Avenue for a moment. Practice questions. So I'm looking at MT to MP3 midterm PQ. Ah, yes, good. So, determinant of a matrix is an excellent practice study question for 2D arrays because it actually uses 2D arrays. First to say 20 isn't. Yeah, there are only 2 questions there because I used the rest for assignments. And let's just see if there's anything exam-y that might be useful. Keep in mind these questions were designed for longer tests. Happy numbers would be, I think, a good practice for the test, even though it's not a 2D array question. Peg solitaire. Yes. Do peg solitaire. Yes, 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 yes. Yep. I don't think that it requires any dynamic memory allocation. Yeah. Do the peg solitaire question as practice. There we go. This is the question. So you're looking MT to MP3 exam PQ question 4 peg solitaire. Do that question. That will be excellent practice for the test. Also, just excellent practice. You'll also probably say, oh my god, he put this on an exam, and then you'll be sufficiently afraid. There you go. Do all the subarrays have to be the same size? In statically defined arrays, yes. So there are basically 2 ways of going about it, right? This way that I've described here, this is what we call statically defined. Basically, what C is doing is it's taking each array and considering it to be a whole data type, and whatever the bit width of that array is, because it's a static array, it's fixed. So they can just plunk in a bunch of them in memory. So this is a static array. This is in contrast to an array of pointers, right? An array of pointers is different. We have it here, yeah. So if you have an array of pointers, these pointers point to, memory that might be all over the place. You only have like an array of size. The size of the array could be dynamic, could be fixed, or it could be static. But because you're linking to other memory and it doesn't have to be in place, then the sizes of these arrays can be variable. But in our case, yeah. In our case, we're talking about the other type, the type that I demonstrated. Good. So instead of plus plus, we would offset of whatever the number of elements are in a single array. If you wanted to traverse vertically, yes. Are 2D arrays the only hard gimmick on the midterm? Gimmick? That's a little insulting. I guess you'll just have to wait and see. How would you compare the caliber of midterm questions versus assignment questions versus exam questions? So in general, the midterm questions are designed to be done in less time. So they're a little more paint by numbers, but, in general, I don't know. I'd say about medium strength questions. It's not shell sort, let's put it that way. I wouldn't ask you to do, like, shell sort on the exam or the test. But, yeah. This is actually the first, like, this is my first offering of this course. I've been teaching this course for 3 years now. This is the first one that I'm doing, like, an in-person test for. So I'm having to, like, that's why my previous question examples are, like, they were designed for online tests that were longer. I used to do tests in, like, a 24-hour format, but now, what with, basically the second year I did that, everybody got wise to the fact that they could just cheat, and everybody started just cheating, so this is why we can't have nice things. We're back to in-person. Yeah. Will the arrays in a 2D array always be in adjacent memory? Yes, because everything inside of an array is always in adjacent memory, including other arrays. So yeah. All right. Oh my god, we've wasted pretty much the entire class. Let's go. So, the following are valid operations on pointers. We've got plus plus, minus minus, plus minus, plus equals, and minus equals. In each of these cases, the numbers you are adding or subtracting to or from the pointer is implicitly multiplied by the bit width or the byte width of the data type. So, for example, if pointer points to an integer, then pointer plus 4 would actually move the pointer by 16 bytes, since the bit width of an integer is 4 bytes. Pointers may also be subtracted from another, but only meaningfully if they point to the same array. Pointer A minus pointer B yields the number of array elements difference between the two pointers, not the number of bytes difference. So if you perform subtraction on these two pointers, first of all, they have to be of the same type, right? They have to point to the same array. So they have to be of the same type because of this calculation, right? They have to be in the same array, otherwise you'll get random nonsense garbage. And they will yield the difference, right? They'll yield the difference between two pointers to the same data structure. In terms of index numbers, right? It's probably a good idea to run that through an absolute value as well, because you might get a negative. Like if you just assume that it's going to come out positive, it may not come out positive. So if you might want like the absolute value of the difference. So good. A word to the wise. In the previous example tracing a character array, we used our knowledge that strings are null terminated to set a stopping condition for the loop. Like so. Pointer arithmetic can easily place a pointer outside of the bounds of its original data structure. There is no built-in protection against out-of-bounds pointers, so we can easily use them to assign to memory outside of the array bounds. So, yeah, you can dereference a pointer that is outside of an array and overwrite all kinds of things, other variables. You can cause seg faults, and you can cause yourself many other troubles as well. While desktop operating systems protect against this sort of thing, embedded systems do not always have these types of protections, especially older ones. Note for you mechatronics students in the crowd. Which should be all of you. Basically, embedded systems often run extremely lightweight operating systems that don't necessarily have all of the, protection subroutines running that you would normally expect. So these can be issues that actually matter. Fortunately, embedded systems tend to be reasonably easy to reset. So, let's talk about wildcard pointers. Normally, pointers require compatible types to be assigned to each other. The exception is a void pointer. So, you use the void keyword instead of your data type regular. This is a generic pointer that can point to any data type. Think of it as a pointer that does not carry byte width information. A void pointer is compatible with all data types and may be used in assignment operations freely. The catch is that void pointers do not, you can't dereference them. So because a void pointer doesn't know how many bytes to return for a dereferencing operation, dereferencing operations simply don't happen with it. Yes. What is the best way to avoid these issues? Which issues are you talking about? It's long enough ago. Oh. You mean with respect to embedded systems, operating systems not necessarily having protections against these types of faults? Yeah, the solution is you got to program good. Get good scrub is the answer to that question. Either get good scrub so that you can program in embedded systems, or go back to programming on computers where you belong, where the operating system will clean up your whoopsies. In that case, what is the use of a void pointer? We're going to see a few examples of them later on with library functions, where a function doesn't necessarily know what data type it's supposed to be returning, so it will return a void pointer and expect you to cast it to the type that you wanted it. Oh, pointing outside of the bounds of its original data structure. Yeah, again, this is just like you have to perform the checks manually. You know? You just have to put the if statements in. You know? That's up to you. So. So, operators in general, miscellaneous operators. Equality and relational operators work on pointers. So, relational operators are only meaningful if pointers refer to the same data structure. If we can subtract 2 to find the difference, we can also compare the 2 to find which is greater. Equality comparison with null is quite common. Checking to see if a pointer is null before dereferencing it is a good idea. Array indexing is actually syntactic sugar for pointer arithmetic, as I've stated previously. Therefore, it is also possible to index pointers in the same ways as arrays. So this means that you can also use square brace notation on pointers as if they were arrays. They're not, but you could use them like that if you wanted to. One of the few differences between pointers and arrays and array identifiers is that array identifiers may not be assigned to. We can think of them as read-only pointers. So, functions. We're going to, let's switch gears a little bit, now talk about functions and function pointers. So, things that are true. Pointers point to memory addresses. Functions are stored in memory. Ergo, pointers can point to functions. That's right, folks. Pointers do not necessarily just point to memory. They can also point to procedures. In C, a function name is really the starting address of that function's instructions. Pointers to functions may be passed to functions, returned from functions, stored in arrays, and assigned to other function pointers. Pointer arithmetic doesn't make a lot of sense, though. So, basically, functions can be passed as arguments to functions. This, if C was a pretentious language like Python, it would therefore claim to be a multi-paradigm language, because that's all it takes for a language like Python, C++, or Java to claim to be a multi-paradigm language is, oh, we can pass functions to functions. We can pass functions to functions as arguments. It's like, okay, but C can do that. Some programming languages, notably Haskell, in some programming languages, notably Haskell, passing functions as arguments is commonplace, very commonplace. Just like most things in C, C can do this too. You just need to be willing to use some elbow grease. So let's consider this guy right here, right? Int compare, right, with a star there. This means that this is a function pointer, right? We apply the pointerization to the identifier, and then provide a list of arguments inside of the list of arguments. Right? The third argument is declared as a pointer to a function, taking two int arguments and returning an int. Compare is the identifier we are giving the function, and the parentheses bind the star character to the function name. Without them, this would be interpreted as a function returning an integer pointer, rather than a function taking a function pointer, right? Bind to the identifier, that makes it a function pointer. Don't bind it to the identifier, it will automatically bind to the integer. That will make it an integer a function returning an integer pointer. Cool? So here's an example from which that's taken. You'll notice we have this here. Inside of main, you'll notice we have somewhere here. Yes. So when we call bubble, we pass it either ascending or descending. The interesting thing about that being, ascending and descending are, I know this is like a long code example, ascending and descending are functions which are defined outside, right? So ascending and descending are functions. We pass them into the function as arguments. We don't have to even put the address of operator on them, because they're already pointers to the memory address that contains the procedure. Cool? So, in this example, we first... so we are scanning to read whether the user wants the thing sorted in ascending or descending order. 1 for ascending, 2 for descending. There we go. It's actually else for descending. We pass these guys in, and then our output is enter 1 to sort in ascending. So for ascending, we get 1. There we go. Original order, and then in ascending. 2, original order, then in descending. There you go. When the function pointer is passed to another function's arguments, is it just dereference function name, or is it just function name being passed with its arguments? Excellent question. Let's see how this thing's being called. So the function call line is right here. You'll notice that the arguments are being provided exactly the same as you would provide arguments to any other function. But yes, we are dereferencing the function pointer inside of this function call. So that you're correct. You do have to dereference the function pointer. And to make sure that this star character binds correctly, you need to provide the round braces binding that to the function name rather than just having it hang out. Good question. So, I've kind of explained all of those points. So, good. Just like everything else, we can organize function pointers into arrays. So, again, we bind, in order to do a function pointer, we bind the pointerization operator to the identifier rather than having it by default bind to the data type, and we have to provide the arguments. How is put s different from print? Where is it? Oh, there it is. I don't know. I can't get derailed by that right now. Look it up in the standard library. To declare an array of function pointers, once again, we bind star to the identifier with parentheses. Additionally, a list of argument types is provided immediately afterwards. The 3 ints above indicate the function's typing information. In this case, all functions in the array accept 2 integer arguments and return an integer. So, in the same way that all of the elements of an array in C must be monotyped They must all have the same type. All of the functions in an array of function pointers in C must have the same function prototype, essentially. The data types that you put in and get out must be the same for all of these functions. Array sizing follows normal rules. Since function identifiers are pointers to functions, we can use them directly to initialize our array. So, here's an example. We declare functions 1, 2, and 3, both taking an integer and returning void. They are defined as just printf, printing f, just printf statements which say which function was called and printing the value passed. We have a void star f3 int comprised of function 1, 2, and 3. This allows us to, in this case, we're polling the user to get which function they want to run, but we could easily also run through a bunch of functions by index by using this as well, right? You can loop over these now because they're in an array. You can access the different functions via indexing. So you can see our choice is just input into the array as we would normally do that. And when you run this program, entering 0, 1, 2, and 3 just calls functions 1, 2, and 3 respectively, and entering 3 just ends the program. What is size t? Where is that? Where did we see size t? Size t is generally provided as the size of the typing. Oh, here it is. Yeah, so size t is like, what is the size of the data type that I'm operating on? So in this case, when we call bubble sort is being passed size, which is a macro. That's being defined here as 10. So, yeah. Yeah, that's just like how many items am I processing? Remember that once we pass an array into a function, we lose the information about how we lose the information of how big that array is. There's no way to tell. So you have to pass the size of the array in with the other array arguments. %u is unsigned integer. Yeah. Right here. Yeah, that's just u is unsigned integer. So, let's get briefly into dynamic memory allocation, or should I say, dynamic memory allocation. Dynamic memory allocation is an evil subject that you will come to hate. So, up to now, our array sizes have been hard-coded, that is to say, set in the program code itself, and not set at runtime. In this section, we will learn how to allocate memory dynamically, allowing us to expand or contract arrays as needed at runtime. When we use static arrays, these memory operations are implicit. So these operations are being performed in the background regardless as to whether you understand that they are or not. So we're going to learn how to use them specifically. The general procedure is to declare a pointer, invoke a memory allocation operation, and store the resultant memory address in the declared pointer. We will learn about such wonderful things as malloc, free, calloc, and realloc. You'll want to bookmark these because these slides will make good reference for future assignments. So, when we allocate memory, the memory allocation operation returns a pointer to the memory that was allocated, right? So, dynamic allocation of a single large block of memory given a specific size, right? So, malloc takes as an argument the number of bytes to allocate expressed as an integer. So, if you want to allocate enough space for 100 integers, you put a 100 here, and then you multiply that by the size of int, right? If you want 100 characters, 100 times size of char. Malloc produces a void pointer because despite, like, this just evaluates to some number of bytes, right? Malloc doesn't know what type of data it's allocating for. The way that you tell C how to segment the allocated data up into individual parcels is to cast it as a pointer to whatever data type you want to use, right? So if you're allocating integers, you have to cast malloc as an int pointer. Are function pointers on the midterm? No, I previously said that the last piece of midterm material was the end of the pointer arithmetic section. Pay attention, please. So, malloc may fail if the requested memory is larger than the available memory. So, if you ask for like 11 billion bytes of memory, the computer's going to say no. If the computer says no, it returns a null pointer instead of a regular pointer. Therefore, after you have performed an malloc operation, you must always check to see if the pointer it returned is null before using that space of memory. Because probably the very first thing that you'll want to do after you have declared this memory or requested this memory be given to you is to put something in it, probably some kind of initial value. The initial value is going to use assignment. Assignment uses dereferencing. Dereferencing of a null pointer results in a segfault. So, if you don't want a segfault, check to see if it's a null pointer before you dereference it. Bing, bang, boom. Good. Any questions? Why isn't the star next to malloc instead of... because then it wouldn't be a cast operation, right? So, okay. That's actually that's a good question. So, let's just copy this line down. Int pointer is equal to int star malloc 100 times size of your mom. So here's the difference, right? This is how things would get interpreted in the opposite case, or the case that you're describing. If you just put a star here, right? C will perform the following operations in the following order. The first thing it'll do, it'll go to the the innermost function call and compute that. So the first thing it'll do is calculate the size of your mom. Let's just say that's large, right? It'll substitute large into the expression here. It will then perform this multiplication, right? So produce very large as a number. This is a joke, right? You guys get this is a joke? Hopefully. So it will then perform the malloc operation and off in memory a size, a size, a chunk of contiguous memory the size of 100 times the size of your mom will be set aside, and a pointer will be returned by that. So this will be substituted for a memory address, like XFF, garbledy-gook, right? Some pointer to some point in memory. Then you have this, a dereferencing of that pointer, right? So you dereference that address, that will return the first element, that'll return the current value of the first element in the newly allocated memory, right? Which will be 0, or some, like, garbage value. Garbage. So that'll be a garbage value, right? That garbage value then gets assigned to this pointer, and that'll happen. So pointer's new value will be garbage. The pointer to the memory cell that, the pointer to the memory cell that you just created will be lost because it's no longer stored. So in comparison, for this one, once we've performed these operations, right, malloc, again, finds a pointer, right? This pointer is then cast as an integer pointer, right? That does not modify the value, right? What it changes is the underlying data type. So implicitly, C is keeping track of this. Implicitly, this is associated with a void pointer. Because a void pointer doesn't carry information about how big the chunks are, it can't be dereferenced. But once you've overwritten it to an int pointer, that's what that operation does, then not only can you assign it to pointer because they're now of the same data type, the address is not modified, right? And now it can be dereferenced. So that's how that operation goes. Does that make sense? Can I have variables in malloc? Example, yeah, you absolutely can have variables in malloc. In fact, that's like, you have just hit upon the crux of the whole power of the, this is why malloc is so powerful, is because you don't have to statically hard code the size of the things that you're creating with malloc, right? Yeah, it can be a variable. It absolutely can be a variable. The expression in here is just a regular C expression. Any valid C expression can go inside these braces, so long as the value that's eventually calculated is an integer, and that's really for our benefit more than, for the program's benefit. If you produce a floating point, if you produce a float in here, right, it will interpret it as being an integer, and as we know, that produces a very long, possibly negative number, right? This will be interpreted as an unsigned number, so, however that changes. And then this is the number of bytes that malloc will try to find space for. It's entirely likely that it will not be able to allocate that much space, so it'll give you a null pointer, right, which will be interpreted as an integer pointer, so the value of the pointer here will be null, indicating a negative or a failed operation. Make sense? So make sure it results in an unsigned integer. But yes, general variables are permitted. Any other questions? So hypothetically, using scanf and malloc, you can ask the user to input how big the array should be. Yes. Next question, please. Not even hypothetically. You can do that in practice. Oh, by the way, I asked the TAs to do like review Q&A in tutorial this week, so because the tutorials are getting a little in advance of the lecture material. So if you please bring review questions to the TAs this week, and they'll be happy to like have them do the previous like test and exam questions posted. Have them do that in class, but you have to ask because it's Q&A. Student directed learning. Anyway, I'm gonna log off here.
Good night. I'm wishing you all a wonderful and spooky Halloween.
Goodbye.